To solve this equation, we're going to start by writing the matrix equation. So I have the coefficients matrix, -3, 2, 6, -5, times the variable matrix, xy, equals the solutions matrix, -13, 24. Now, from the notes last time, we showed that the solution to this matrix equation is always going to be the inverse of the coefficients matrix times the solutions matrix. And this is all matrix operations that we know how to do. So the inverse of that coefficients matrix is going to be 1 over the determinant. So -3 times -5 minus 2 times 6, and then times the rearranged version of that matrix. So the entries in the main diagonal switch locations, and then the other diagonal has opposite signs. So because the 2 and 6 are positive, they now become negative. And we still have times that solutions matrix. So now I have 3 things multiplied together, right? I have one scalar multiplication and one matrix multiplication to do. You can do those in either order that you want. I'm going to choose to do the matrix multiplications first because it lets me avoid having to add and subtract any fractions, which is a little bit nicer. So 15 minus 12 is 1/3. That's still out front. And then if I do row 1 times column 1, I get 65 minus 48. And if I do row 2 times column 1, I get 78 minus 72. So I have 1/3 times the matrix 17, 6. And when I do that scalar multiplication, I get 17 over 3 and 2. So x is 17 over 3 and y is 2. That was the most involved problem on the sheet. It was the only one we asked you to do by hand. Everything else you should have used your graphing calculator to kind of handle the solving part of it. All I would have needed from you on the rest of these is just the setup, and then you would have gone to your calculator to do all the heavy lifting for us. Let's go back and look at number 2 now. So here it says write the system as a matrix equation and then solve that matrix equation using our calculator. Okay. So I'm going to set this up the same way I did before. I'm going to have the coefficients matrix. So that's 7, 4, 5, 3 times the variable matrix xy equals the solutions matrix 6, -25. Now it's calculator time. I've written the matrix equation as was asked in the problem. To solve this matrix equation, I'm just going to do the inverse of the coefficients matrix times the solution matrix. So go to my calculator, and I'm going to enter in my coefficients matrix. I put mine into matrix A. And then I need to enter in my solutions matrix. I did that in matrix B. So now all I need to do is my calculator. I need to do A inverse. Oops. Times B. So that tells me my answer is for x is 118, and for y it's -205. Boy, that was pretty quick, right? For number 3, again it says write the system as a matrix equation and then solve in your calculator. Okay. So I'll start by writing my coefficients matrix. 1, -6, 4, 1, 1, -4, and then 2, 2, 5. That's my coefficients matrix. My variable matrix would be just x, y, z. And my solutions matrix, -12, 12, -15. Everybody happy with how I set that up? Okay. So to solve this, I'm just going to do the inverse of the coefficients matrix times the solution matrix, and I'm going to use my calculator to do that. And in fact, right now you guys have no idea how to do that, this particular one by hand, because we don't know how to find the inverse for a 3x3 matrix. Not something we'll do in this class, beyond the scope. If I ever ask you to do that on the test, you rest assured you should be using your calculator to do that sort of thing. All right, so I'm going to enter my coefficients matrix into matrix C. You can see I already did that before class. And I'll enter my solutions matrix into matrix D. Oops. Into matrix D. And again, you can see that I already did that before class. So I will then do C inverse, inverse times D. And so I get that x is 0, y is 0, and z is -3. Everybody okay with what I've done here? Not too bad, right? Okay. 4, 5, and 6, we're asking you to do something slightly different. 4 says write an augmented matrix and then solve the system using Gaussian elimination. Okay, so my augmented matrix is 1, 2, 6, -5, and 1, -1, I'm sorry, -1, 1, -2, -3, and then 1, -4, -2, 1. So I'll go ahead and type that into my calculator. I'm going to type mine into matrix E. As you can see, I've already done that before class. And then to perform Gaussian elimination on my calculator, I need to use the RREF command. So I'll go back to the matrix menu to retrieve that command. I'll move over to the Math tab, and all the way at the bottom is that RREF command. And I'm going to perform that on my matrix E that I just put in. So I'll go to matrix E, and I'll do that, and press enter. Now you notice that I got some wacky decimals there. It might make more sense if I look at this with some fractions in it. To turn this into fractions, I'm going to press the Math button, and then select the frac command. And now somehow this matrix that I have tells me my answer. What part of this matrix is going to tell me my answer here? What should I be looking at? Not the fraction. I'm looking at the last row. So the 0, 0, 0, 1. What does that last row say?
0x plus 0y plus 0z equals 1.
Excellent. 0x plus 0y plus 0z is equal to 1, which simplifies down to just 0 is equal to 1. And what does that tell me? Yeah, so I would say no solution. 118 and -205? So 5, doing the same thing. We'll start by making our augmented matrix. Once I do that, I'll go ahead and type that into my calculator. I'm going to type mine into matrix F. You can see that I've already typed that in before class today. And then I'm just going to do that RREF command to matrix F. So again, the RREF is in the Math tab of the matrix menu. I got some crazy looking decimals here. Let's do math frac to make those fractions. And then somehow this is supposed to tell me my answer. What part of this matrix am I need to look at to figure out my answer? So if I look at the third row, where it says 0, 0, 0, 0, what does that mean? Yeah, 0x plus 0y plus 0z is equal to 0, or just that 0 equals 0. What does that tell me then? We have infinitely many solutions. But remember, we don't stop there for infinitely many solutions. We want to describe that general solution set. And I can do that just by using the first 2 rows of my matrix. So if I look at that first row, that tells me 1x plus 0y plus 21 over 11z is equal to 18 over 11. And the second row says 0x plus 1y plus 15 over 11z is equal to negative 17 over 11. What I'm going to do next is I'm going to isolate the x's. So I'll subtract 21 over 11z from both sides. And similarly, I'll isolate the y's by subtracting 15 over 11z from both sides. So what that tells me then is that my x is equal to negative 21 over 11z plus 18 over 11. My y is equal to negative 15 over 11z minus 17 over 11. And since I've written both x and y in terms of z, the z is going to act as my independent variable, and I'm just going to leave that as z. So there is my general solution set. I would expect that you're able to do that on the test. So you should be able to write a general solution set for an infinitely many solutions problem on the test. We have one more problem on the back. So again, the directions say to write this system as an augmented matrix and then solve using Gaussian elimination. So I'll start by writing my augmented matrix. When I get to row 2, though, notice that I don't have a z variable. So I'm going to need to include, there's a spot in my matrix for the z variable. In that spot, I need to make sure I write a 0. So notice where I put the 0, it was right in line with all the other z's. The 0 went in the column for the z variables. I have to make sure I put the 0 there as opposed to, say, in the first column or something. Again then, Now that I've got my augmented matrix, I'll go to my calculator, enter in the values. You can see that I did that before class. Then I go to my Math tab, select the RREF command. Oops. Got to exit out, and then go to my Math tab and select that RREF command. And I'm going to do that to my matrix G. And then where do I look for this one to get my solutions? What does row 1 say? It says 1x plus 0y plus 0z is equal to negative 5, or just that x is negative 5. What does row 2 say? 0x plus 1y plus 0z is equal to negative 5, so y is negative 5. And what does row 3 say? 0x plus 0y plus 1z is equal to 3, or just z is equal to 3. And if you wanted to write that as a tuple, you could write it this way. Any questions on that assignment? Okay. You will need to be able to use your graphing calculator to solve systems of equations using matrices for the test. There will be a couple of systems I'll ask you to solve by hand. There'll be more systems that I'll ask you to solve using your calculator, because I can't honestly expect you to solve like 10 sets of systems inside of 65 minutes. That's unrealistic. But these ones where we use our calculator, you can do in just a minute or two. Much more realistic to ask you to solve a bunch of those and do stuff with that in a test setting, right? Because time is much less of an issue there. That being said, you need to have your graphing calculator, and you need to know how to use your graphing calculator to solve these systems. Okay? The last topic that I wanted to cover in this unit is some applications. So the first application would be like a story problem situation. There's just one C. Suppose that you sell vacuum cleaners door to door. You have a basic model that sells for $65 and a deluxe model that sells for $175. If you've sold 22 vacuums for a total of $2,420, how many of each type of vacuum have you sold? So the first thing I would do is I would start by picking a variable name for each of the things we're looking for in this situation. So I'm going to use B to be the number of basic vacuums. And I'm going to use letter D for the number of deluxe vacuums. Everybody okay there? So then I'm going to look at what I know, and the thing that sticks out to me in this problem is that I'm given two totals, right? I sold 22 vacuum cleaners, and I've sold those vacuum cleaners for $2,420. So I'm going to write two different equations that when I add stuff up, one of them I get the 22 total vacuum cleaners I've sold, and the other when I add them up, I'm going to get the total of $2,420 that I've collected from my customers. What's the equation I can write that's going to sum up to be 22? Okay, so that wasn't the equation I asked for, but that's true. So what Annalise says is that 65B plus 175D is going to equal 2,420. That the 65 times B is the amount of money that I collected from the basic vacuum sales. And the 175D is the amount of money I collected from the deluxe vacuum sales. If I add up the deluxe money and the basic money together, I'm going to get the total money that I've brought in. Everybody okay with how we did that? Okay. What's the second equation I can write? What haven't we used yet? The 22, right? So whatever this equation is, it's going to involve that 22. That's all it is. B plus D is equal to 22. Well done. If I've sold 22 vacuum cleaners, that must be the basics and the deluxes added together is the 22. So all I need to do is solve this system then. How do you want to solve this system? Well, if you guys don't care, I'm just going to do Gaussian elimination on my calculator. Basic mostly because it's fast. So I'll make a 2 by 3 matrix. The entry is 65, 175, 2420, 1, 1, 22. Then I'll exit back to the home screen, go back to the matrix menu in the Math tab, retrieve the RREF command, and do the RREF command on my matrix H that I just put together, which gives me this. What is this telling me? Well, that I sold 13 basic vacuum cleaners and 9 deluxe vacuum cleaners. Everybody okay with how I interpreted that matrix at the end? That's not too bad, right? What's the hardest part of this? Probably writing the system, right? If you can get the equations written down, it's easy to get it into your calculator. So the place where you probably want to pay the most attention and be the most conscientious with your practice is on writing those systems. The second application is going to be a callback to the previous chapter, where we can use a system of equations to figure out the standard form equation for a quadratic that passes through any three given points. So remind me again, when we talk about the standard form equation for a quadratic, what does that look like? Who remembers that? It's only a chapter ago. You should still remember this. Let me help. Starts y equals a x squared plus bx plus c. Thank you, Andrew, maybe from the back. That's the standard form equation for a quadratic. If I wanted to write that, what three things do I need to know? I need to know a value for A, a value for B, and a value for C. So let's show you how to do that. So let's say we want to write the standard form equation for the quadratic that passes through the 3 points, negative 353, 19, and 661. So I have three variables I need to solve for. I need to find a value for A, a value for B, and a value for C, right? How many equations am I going to need then? 3. If I have three variables, I need 3 equations. Okay? So what am I going to do then? Well, I have a bunch of values for x and y, right? I can plug those values for x and y into my standard form equation, and I'd have a times 3 squared, or negative 3 squared, excuse me, b times negative 3, plus c is equal to 53. Notice that all I did was plug in the values for x and y to my standard form equation, but I wrote the equal sign on the right-hand side like we typically do when we write a system. Everybody okay with that? So that's using 1 point, and I got 1 equation. How am I going to get the other 2 equations? Doing the same thing with the other 2 points. Exactly right. Yeah. So if I plug in 1 for x and 9 for y, and then plug in 5 for x and 61 for y. So there's my system. How do you want to solve this system? Do Gaussian elimination, right? That's so fast. Mr. Kulik hasn't specified that he needs it done a certain way, so heck with it. I'll do it the fastest way I know how. So this will need a 3 by 4 matrix. And then negative 3 squared is 9. I have a -3 coefficient, a 1 coefficient, and a 53. Everybody okay with that? So I had 9, -3, 1, and then 53. And I'll do the same thing for the next two rows. So 1 squared is 1, and then 1, and then 1, and then 9. And then 5 squared is 25, and then 5, and then 1, and then 61. Now that I've got my matrix written, I'll just exit back to the main menu, go to my matrix menu, pick the Math tab, go down, select RREF, and do that on my matrix H that I just wrote. So what is this matrix telling me? A is 3, B is -5, and C is 11. So my equation then would be 3x squared minus 5x plus 11. And I guess I didn't say the y equals, but y equals 3x squared minus 5x plus 11. Everybody okay there? So that should be even easier, right? Than the previous problem. Why is that a little bit easier? Because writing the system is really easy, right? Because you know what the equations in the system are going to look like. They're just going to be ax squared plus bx plus c equals y. And you know exactly what you're plugging in for x and y because it's just the x and y's from the points that you're given. Should be really easy to write that system. Everybody okay with that? Those should be easier. This next one is a matrix application. And it's a geometry application. So we can use a matrix to calculate the area of the triangle given the vertices for the triangle. Just as a little vocab review from your geometry course last year, when we talk about the vertices of the triangle, what are we talking about? Like the tips, right? Just the points at the ends of the triangle, right? Okay. So, suppose we want to find the area of the triangle with the vertices -3, 5, 1, -6, and then 5, 1, maybe. Well, if you were in your geometry course last year, you probably did some problems that looked pretty similar to this, where the first thing you would have done was to graph your triangle. So -3, 5, 1, -6, and then 5, 1. So our triangle kind of looks like that, right? And if we were doing this in our geometry course, what would have we used to calculate the area of this? You guys should remember this. Okay, 1/2 base times height. So which side of the triangle is the base? Doesn't really matter, but I'm taking from the bottom, you mean that side. And how would you figure out the length of that? You can use the distance formula to calculate that length, which is not that bad. And then where's the height then? The height is not either of the two sides.
It's the middle. It's going straight up. Oh, it's that. Yeah.
And how are we going to figure out the height, the length of the height?
A ruler. 1/2 of the base.
It is not anything to do. It is not twice the base.
I don't know.
You would need to write the perpendicular or the equation for the line perpendicular to the base. Then you would find the intersection of that line in the base. And then you'd use the distance formula to calculate the length. And this is now starting to sound pretty awful. Yep.
So awful.
Who doesn't like this geometric approach? Yes, it's really quite terrible, right? This is a worst case possible scenario if we ask you to find the area of the triangle in a geometric set. This is probably like a 20-minute problem all of a sudden. We can do this in about 20 seconds using a matrix. What's up? All right. So, if I do this using a matrix, this boils down to a simple formula. That area of a triangle formula is plus or minus 1/2 times the determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. Well, let's show you how this works. So for our triangle, the first point was -3, 5. The second point was 1, -6. And the last point was 5, 1. So we're going to take the determinant of the matrix -3, 5, 1, 1, -6, 1, and 5, 1, 1. Okay? Well, I'll go and type that matrix into my calculator. Once I have that typed in, I'm just going to do 1/2 times the determinant. So to get the determinant command, remember we go to the matrix menu in the math tab. It's the first one. And we're going to take the determinant of that matrix H that I just wrote. And I get 36. The only thing that we haven't talked about yet is how to deal with this plus or minus. What should the sign of an area be? Positive always. Since when I did 1/2 the determinant and I get a positive value, I should select the positive from the plus or minus because I know I need to have positive area. So I'm done. We did that in about 20 seconds. Much better than the previous thing where we're having to muck around with the distance formula and finding the equation for a perpendicular. And yeah, that was really quite quick and neat. Because you know what a matrix was, and we spent 2 weeks talking about matrices. next week sometime, probably. This is the last set of topics. So, Addie. Of course. So really, with this plus or minus, all you're doing is selecting the one that makes your answer positive. So what is this plus or minus really doing? It's basically like an absolute value around this whole thing, but I didn't want to write an equation with an absolute value and a determinant symbol in it, because that it feels like I'm abusing the heck out of the vertical bar notation to mean two different things inside of the same formula. So I just wrote it as a plus minus instead. Then you're going to use the negative from the plus or minus to make minus a negative or a positive. Exactly. And what you pick as x1, x2, or x1, y1, x2, y2, and x3, y3 doesn't matter. So just to kind of illustrate this to you, if I go back to that matrix H, and maybe I did 5, 1 in the second spot, but did 1, negative 6 in the third spot, and I do the same thing again. Notice the only thing that can possibly change is the sign, which because it's plus or minus and we just make whatever it is positive, it doesn't really matter. So what you pick as x1, y1, x2, y2, the point doesn't matter. You can do them in any order you want. They just have to match up, right? Like you can have x1, y2 or something like that you can't do. So it doesn't even matter which one you put in which order. Okay?